In this video, we'll look at how to create scripts which will allow you to automate a lot of the tasks that you would normally have to type from the command line, and we'll look at how to run Linux commands in the future. Let's look at shell scripts first. Shell scripts are executable files that contains Linux commands. They're very easy to set up, and you can use any text editor to create a shell script. There's a couple of conventions that you must use in order to create a shell script that works. The first is at the top of the file, you must indicate the shell that's going to be used to run the commands within the shell script. Here you have the number sign followed by an exclamation point. In Linux nomenclature, this is known as the shebang. Then you need to show the path and the shell that you're going to be using to run the script. Typically, the Bourne shell, the original shell, is used. However, you can use any other shell that you feel is appropriate, including Bash, CSH, or TCSH. Finally, you must make the shell script executable, and you do this by changing the file permissions to set the execute bet on the appropriate user, group, or other. So let's take a look at an example that I downloaded from the internet from this site. So the first line is as it should be, shebang followed by the shell, which in this case is the Bash shell. And if you notice on the left hand side, there's a number of number signs in here, and these indicate a comment. So you can comment your script so it's clear to both you and other users exactly what the code does, and this is always a good convention to use. Next, you have a capitalized log underscore dir directory, which is a variable. So we're setting the variable log_dir equal to the directory var log, which is where log files are kept. And so the first command that's executed is you cd to the var log directory. Notice that there is a $sign in front of log dir, meaning use whatever this variable has been set to. And then we're going to cat the contents of the device dev null, which simply means to empty the contents of the messages file and the wtemp file. So what this is doing is it's overriding messages in wtemp so it has no contents. Notice the redirection operator. Finally, echoed to the screen is the text logs cleaned up, and then the file exits. Notice again that there's a $sign here indicating that this is a comment. So let's look at a simple illustration of a script that I created. So we open up our text editor and we have our shebang followed by bin sh, so we're using the Bourne shell. Next, we cd to our home directory to a subdirectory called examples, and of course this would have to exist, otherwise this command wouldn't work. Finally, we're going to create 5 empty files using the touch command. Touch 1, 2, 3, 4, 5. That creates 5 empty files. Then we echo the text hello world, and we append that to the contents of file 5. After this would mean that there would be 4 empty files, 1, 2, 3, 4, and one file, 5, which contains the contents hello world. We then echo the text created files to the screen, and then we cd to the parent directory. Let's run that. So let's use vim or vi to let's call this create empty files, which isn't exactly correct because we are creating one file. So let's start out with the shebang, whoops, and indicate the path of the shell. And so we're going to cd to my home directory in the examples directory. We're going to create some empty files, which we've done with touch, and then we're going to echo hello world and append that to file 5. Then we're going to echo to the screen and then we can cd to the parent directory, and we can exit the script. Let's save that. So now let's take a look at that file. Notice the permissions are read write for user and owner, read for group, and read for other. We need to set the execute bit for either user, group, or other. Let's allow everybody to use this file. So we can change permissions to chmod, and read write execute is 7. Read and execute is 4 plus 1 is 5. And for other, read plus execute, 4 plus 1 is 5. And create empty files.sh. And so you notice it's read, write, and execute for user, read and execute for group, and read and execute for other. So anybody can use this. Any user, anyone on the system can execute this file. Okay, the next thing we need to consider is its location. Notice that it's in my home directory, and so if I try to execute this just using create empty files, I'm going to receive an error message, command not found. And that's because it's not in my path. When we are executing most of the commands, for example rm or ls, notice that these are in the binary directories, and these will be in our path. This directory will be in our path. If we echo our path to the screen, we will see that the bin directory is in our path, and that's why we can just type rm or ls or any number of 100 commands, because the commands will be located within a directory that's in our path. If it's not in our path, we will receive a command not found. So we need to indicate precisely where this file is. So we indicate it's in the current working directory, create empty files. We can use tab completion, hit enter, and let's go to our examples directory, and notice that the 5 files are completed, and file 5 has the appropriate contents. So that was a silly little example that illustrated how a shell script works. And shell scripts can be quite useful because any task that's automated where you used to issue a lot of commands is better done with a shell script that you can debug once and then run it many times. Let's do one more example. So we've got a directory already called examples. We've already got a file called create empty files, and we've already run it once. So we're all set up for the remaining parts of creating a shell script. So we want to create a new shell script that can be located anywhere in the system that removes all empty files from the directory examples, and we want it to print out to the screen examples clean afterward. We want to name this script remove empty examples.sh. We want to make it executable for the owner only, and then we want to copy this to another directory. Here I said etc, but let's do something a little different and put it somewhere in our path. Then we want to run the command, and then check back in the examples directory to make sure it worked. Let's try that. So we want to open it and create a new file, remove empty examples.sh, and we've created the new file, shebang bin sh. We have a comment, removes empty files. And now what we need to do is to find the appropriate command that will do what we want it to do. So the best command I know to do that would be the find command, because we can not only find files meeting a specific criteria, but we can also execute commands based upon what we found in the results. So find, and remember we want to be able to issue this from any command, any directory on the file system. So let's be very specific where we're doing this. Home PC examples. And now we want empty files only. So we can indicate that we want empty files only, and then we can execute the rm command to remove those empty files. So this finds empty files in the examples directory, and actually any directories below that, but this is the only one. And we need to end the command with our braces and the / and the semicolon, and then we want to echo to the screen cleaned examples. I think that's what I said. And then we want to exit. It looks like it will work. And we need to do one more thing, which is we need to make it executable. Let's try to run this right now when it's not executable. Let's see what happens. Remove, empty. Notice that tab completion doesn't work. That's because Linux knows that that's not an executable command. Permission denied. And essentially that's not it's not a good description of an error, because it's the actual error is that it's not executable. So let's only allow the owner to run this command. And so we need to set it 7. We can keep 4 and 4 on here, so we can allow other people, others in the group to read it. And then remove empty examples. Let's take a look at the permissions now. So it's read, write, execute. It's execute for the owner only, and everybody else can read it. Now let's copy this. Now let's move it to remove empty examples.sh to move to the user local bin directory, because that was the first directory in our path. That's my password. And now let's make sure it's there. User local bin, and it's there. And now we don't need to indicate where it is because it's in our path. So notice I've only typed remove dash and I hit tab, and it completes it. And I typed enter. We get our message cleaned examples. Let's make sure. And you see all the empty files were deleted, but the file that had some content in it remains, so it worked. Remember, if you need to run a lot of different commands every day, it's much better to put it in a shell script and debug that shell script and just use that shell script on a daily basis. Or you could set it up using one of the techniques we'll discuss shortly to run it on a regular basis so that you can get your work done. Now let's look at time-based commands, that is, running commands at a later date. Because sometimes there is a need to run commands not immediately, but you need to schedule them for a later date. For example, let's say there was something that was going to tie up your machine for a while, so for example, backing up files and copying them to another server. So you might want to run these after 5 p.m. or while you're at lunch. So one of the one-off commands might be at 10 tomorrow, email me this reminder message. How would you run that? You can set this up by using an @ command, AT. And this uses the @ daemon, which should be running on your system, to run commands at a later date. So you can use this for regularly repeating commands, such as every night rebuild the database used by the update db command. That's something you might want to run every day. Later on we'll talk about even more flexible commands using the cron command, which is a little more flexible. So you can run @ interactively by typing @ on the screen and then issuing commands. And I'll show you how to do that shortly. This command is saying @ now plus 2 minutes, which means in 2 minutes you hit enter and you enter the interactive @ command, and then it says PS AUX greater than processes. So in 2 minutes the PS AUX command will run, which lists the processes running on your computer and redirects that to a file called processes. Notice here at the command I typed @q. And this is the queue you usually think of when you're talking about computer science. That is first in, first out. And notice that I have 2 @ commands to be run in the queue at a later date. You end the interactive @ session by hitting the Control D, and that will take you back to your command prompt. So some of the @ commands that you can run: @now and then a command means to run immediately. @now plus 2 minutes means, as we said before, in 2 minutes, or it could be 2 hours, 2 days, 2 weeks, or even 2 years. @now next year means this time next year run this command. At 2:45 p.m. means run the command at 2:45 in the afternoon. And you can see at 15 o'clock today, that's 1500 hours, would be 3 p.m. or at 3 a.m. Notice that this is military time, so just the 3 without the p.m. means in the morning. Or at 5 on the morning, October 9th, 2006, or at 5 in the morning, 10/9/2006. And so you have a lot of flexibility in how you specify the time and date to run the command. So let's look at the example that we did before. @now plus 2 minutes. We hit enter, and notice it indicates that this commands will be executed using the Bourne shell. Now we can indicate the commands we want to run. PSAUX greater than processes. We hit enter. We can hit Control D to get out. Notice that this indicates that job 7 will be run Tuesday, November 9th at 2:55 in the afternoon, 2010. Let's do another command, @now plus 3 minutes. And let's do a directory listing, ls-alr for recursive greater than file listing. Hit enter, Control D, and that will be run a couple of minutes later. Now let's type @q to see what's in our queue. Job 7 will be run in just about a minute now, and then a couple of minutes after that, job 8 will be run, and now we have to wait a minute. Okay, now let's run processes, and you see there's our processes that ran, and let's see if file listing is there. I think I called it this. And that command is not run yet. Let's type @q again. And you noticed that it hasn't run yet because it's still in the queue. Notice that job 7 has already run, so it's no longer in the queue. And while we're doing that, let's do one more command, @now plus 2 minutes. And let's do an MD5 sum of all the files in the examples directory. And so let's type MD5 sum and examples. We're going to put that to a file called files.md5. Hit enter, Control D, let's hit @q, and apparently the previous command that did the file listing is already run. But what I want you to show you this is how to remove that number 9, the job 9. You type @rm9 @q, and it's no longer in the queue. So if there's a command in your queue that you don't want to run, before it runs you can issue the @rm command along with the job number and it deletes it. Let's type less and file listing, was that it? And there's our file listing. A few things to note about the command. The first is it's executed by the daemon. So just to show you that the @daemon is running. Let's type psaux grep @d. And you notice that this is a daemon with PID 756. And there's the @daemon. So we know that it's running. If it's not running, your commands won't work. The @daemon has to be running in order for the commands to work. Notice also that your command has the permissions of its owner. It won't necessarily run as root unless you run it as root. It runs in the directory it was set up in. It has the environment it was set up in. And it does not run in a terminal. Note that the output from the command cannot be included in a terminal window and will be emailed to its owner if it's set up appropriately.